Today we're going to be looking at the law of sines and law of cosines. Our objective is to be able to find angle measures and side lengths using law of sines and law of cosines. So, when can you use SOHCAHTOA? I know that's what we've done so far with our sine, cosine, and tangent. But remember, the only time we can use that is if you have a right triangle. The big mistake that students make is they try to use that all the time no matter what kind of triangle they have. And the reason you need a right triangle is because this H, if you remember, stands for hypotenuse. And the only kind of triangle that has a hypotenuse is a right triangle. So that's going to be the key to why we need the law of sines and law of cosines today. So here are the two sines, laws, law of sines and law of cosines, and this is what we're going to use when we don't have a right triangle. And we're going to go through two examples so you can see when you use one as opposed to the other. Now, law of sines is a set of ratios. So we have sine of angle A over the side A. Remember, uppercase A stands for the angle, lowercase a is going to be the side length. Sine of B, angle B over little b, or sine of C over little c. Now, this is a kind of a run-on equation, kind of like a run-on sentence. You don't actually use all three at the same time. So what you're going to do is pick two of these from the information given to you, set them equal to each other. We can cross-multiply and solve for the missing part. Law of cosines looks a little bit more complicated. We have a squared equals b squared plus c squared minus 2bc cosine of a. A lot of kids think they're not going to be able to remember this, but we do one example and you pretty much have it. If you notice here, whatever the little side is, this is our side squared. And if you look at the equation, the cosine of the angle matches up with the side. So if it's side A, it's angle A. And then we just take the other two sides, b squared plus c squared. And then you subtract 2 times these two sides, b times c. This could have been b squared and b, this could have been c squared and c, and then every letter would change accordingly. And we'll, like I said, we'll go through an example so you can see. So in our first example, it says use law of sines to solve a triangle. And a lot of times I won't tell you to use law of sines or cosines. For your notes I will, and we're going to go through and I'll show you how you know that law of sines is what we can use. So I have a triangle. You don't have to draw it accurately. I mean, you could draw any triangle, just draw 3 sides, and then put in A, B, and C. I like to draw a little bit more accurately because it might help you. I noticed that my angle A is obtuse, so I'm going to actually draw an obtuse triangle. You don't have to, but it might make some problems a little easier for you. So I'm going to call this angle A, and it doesn't matter where you put B and C. And I use uppercase letters for angles, lowercase letter for sides. So angle A is 135 degrees. I like to label it. I know that side A, so little a is across from angle A, is 23. And I see that side B, so the side across from angle B, is 10. So how do I know I can use law of sines? You can use law of sines anytime you have a pair, meaning that the angle and the side length across from it are both known. And since we know both angle A and side A, that's the one I'm going to use. So I'm going to set up sine of my angle A, 135 degrees, divided by the side length, 23. Okay, I'm going to set that equal to another ratio. And which one do I know? Well, I know side B. So if I know side B, I can then find angle B. So I don't know angle B, so I'm just going to write uppercase B. But I do know side B, which is 10. And since I only have one unknown here, I can cross multiply and solve. So if I cross multiply, I'm going to get 23 times the sine of B. And you always put the number in front of the sign. Don't ever put it at the end, because then a lot of mistakes made because then they multiply to 23 by the angle, and that's not what we're doing. Equals 10 times the sine of 135 degrees. Okay. I like to try to get this all by itself first and then type into my calculator, and I will show you how to do that. So I'm going to divide both sides by 23, and I get sine of angle B is equal to 10 times the sine of 135 degrees all over 23. Okay, just by dividing both sides by 23. Now, if you remember, I'm trying to find B, not sine of B, but I'm going to do it step by step. So I'm going to show you what you get when you type this into your calculator. So I'm going to take your calculator out, turn it on, and then you want to make sure that you're in the correct mode. Anytime you're going to use sine, cosine, or tangent, you want to make sure you're in the correct mode. And since we're talking about degrees, again, this is 135 degrees, I need to change this to degree mode. Okay, go back through. I'm going to type this in exactly how I see it. I have the numerator, and if you want to be more careful, put the numerator in parentheses, and a lot of times for this you wouldn't have to do it. 135, close your parenthesis, divided by 23, okay? And we get an answer. But that isn't my final answer, because that's what sine of angle B is, which means, if you remember from what we did in our last section, and I'm just going to write out a few of these decimals just so you have it. Okay. But if you remember, this is asking me a question. I want to know what angle has a sine value of this crazy decimal. Well, to do that, we have to move the sine over using inverse sine. So B is actually the inverse sine, and I'm going to put this here. This is my previous answer, because that's what I would do in my calculator. So I'm going to hit second sine, second negative, and that puts in my answer. Close the parentheses. And now I get that angle B is approximately, and I'll round to 2 decimal places. You know what, let's do 1 decimal place, just to make it a little easier. 17.9, again, we're in degrees, so that's degrees. Okay, so now that we have that, let's see. So now I know B is 17.9 degrees. But we want to solve the triangle. So what does that mean? That means you want to find all missing sides and all missing angles. So we found one missing angle, but now I can actually easily find the other missing angle because I know the 3 angles of a triangle add up to 180. So if I take 180, I subtract the 135, I subtract the 17.9, that's going to tell me what's left over. So 180 minus 135 minus 17.9. And I get 27.1. So let's write that. So we have 27.1. So that's here. They should add up to 360 degrees. So far I know angle A, and little b. I just found big B to be 17.9. And again, it's approximately 17.9 because I rounded. I now know angle C, which is big C, is approximately 27.1. Okay, so what do I need to find now? So now I'm just going to set up another proportion to find my side C. Okay, and I'm going to find out what that equals. Now, if you notice, I have 2 pairs. I have angle A and side A, and angle B and side B. So technically you can use either one, but I always suggest using the one that was given to you in the original problem because you know that's correct. You could have made a mistake with B. So I'm going to set it up as sine of 135 degrees, my angle A, over side A, equals, and now I'm going to set up my ratio for C. I know my angle is sine of 27.1 degrees, but I don't know little c. And it's actually a lot easier to solve for a side length than it is for an angle because you won't have to use this inverse. So what I'm going to do is cross multiply. So I get side C times the sine of 135 degrees equals, and then I'm going to get my 23, again we always put that in the front, times the sine of 27.1 degrees. Okay. But to get C alone, I'm going to have to divide both sides by the sine of 135. So I have 23. I'm going to be dividing by a sine of 135 degrees. And I have 23 times the sine of 27.1 degrees. So I'm just going to type that into my calculator. So again, type it in how you see it. And again, because the numerator is being multiplied together and you only have one term in the denominator, you don't have to use parentheses, so I'll show you that. 23 times the sine of 27.1 degrees, but you do want to close the parentheses, divided by sine of 135 degrees. Hit enter, and now I get side C is approximately 14.8. And again, I don't put a degree symbol because this is a side length, so 14.8. And that's how we use the law of sines. So now I'm going to give you another example, and I'm going to show you that we're going to actually have to use the law of cosines on this one. So I have a triangle, and all I know is angle B is acute. So since that's acute, I don't know I have an obtuse angle, which I could, but I'm just going to do it as a nice little acute triangle. I'm going to call one angle B, I'm going to have an angle A, and an angle C. And again, it doesn't matter really where you put it. So I know angle A is 50 degrees. I know side A is 15, and side C is 20. So if we look here, I don't actually have any pairs. I don't have an angle measure and its side measure to match up. So I can't do law of sines because if I try to set up the proportion, I'm going to have too many unknowns. So this is when we have to use the law of cosines. So how do I know what side I should put by itself? Well, that depends on what angle you know or what angle you want to find. And in this case, I know angle B. So I know if that's going to have the cosine of b in my problem, that means little b has to start. So I'm going to have b squared equals, and then I'm just going to go with my formula. A squared plus c squared, okay, minus 2 times a times c times the cosine of big B. Okay, that's my formula. So I'm just going to start filling things in. I don't know little b squared because that's what I'm trying to find, but I do know a squared. Okay, and again, I don't do the work. I just write 15 squared. Okay, plus, now we're going to do our c squared, which is 20 squared. Oops, let's do that in the right color. 20 squared. Minus 2 times a, which was 15, times c, which is 20, and I know cosine of b, which is 50 degrees. Anytime you're solving for a side length, it's always so much easier than an angle measure, especially in law of cosine. So let me show you what we're going to do. We're just going to type this in exactly how I see it. And technically you don't need the parentheses here, but I just put there so you can see the difference. 15 squared plus 20 squared minus 2 times 15 times 20 times the cosine of 50 degrees. And I hit enter, and now I know that b squared is approximately 239.3274342, and so on, right? But I'm not trying to find b squared, I want to find b. So what a lot of students mess up on a test is they give me this huge number, but they forget that we want to take the square root of that answer. So to find b, and I'm going to just show you the work here, it's approximately the square root of our previous answer. So to make sure you have that down, that's what we have to do. So b is approximately 15 point, we'll just do one decimal place, 15.5. So I know now all three sides. B is approximately 15.5. So now if you notice, we actually have a pair. So some people might want to choose to do law of sines. I do not suggest that, especially in this problem. And I'm going to go on my next slide and explain why, but we're going to stick with law of cosines because this is not my biggest angle. And going back to geometry, 50 is not my biggest angle because 15.5 is not my largest side. My largest side is 20, so actually angle C is my biggest side. My suggestion is if you don't know the biggest angle, do not switch from law of cosines to law of sines. Okay, even though you have a pair, unless you know the biggest angle. And again, I will explain that in the next slide. So we're going to stick with law of cosines. So I'm going to solve for one of my angles. It doesn't matter which one. I'm going to choose to solve for, say, angle C. So let's solve for angle C. If I want to solve for angle C, that means I have to start with c squared. So I'm going to write that formula out here so you can see it. C squared is going to equal, and then we're going to get a squared plus b squared minus 2 times a times b times the cosine of c. And then we're just going to fill in what we know. So I know that this is 20 squared equals a squared plus b squared minus 2 times a times b times the cosine of c, which we do not know. So now to solve, we need to try to get cosine of c by itself. And the biggest mistake that students make is they see all of these numbers and they type all of these into our calculator and get one big number and then divide both sides by it. And you cannot do that because 15 squared plus 15.5 squared minus 2 times 15 times 15.5 is not linked together. These are connected. Okay, this is one term, so you can't combine this without dealing with the cosine of c. So what I like to do first is just move this stuff over to the other side to get this by itself. And to easily do that with our calculator, again, I don't like to do any of the work by myself because I'm going to have to use a calculator anyways. Just write 20 squared. I'm going to subtract 15 squared to move it over. I'm going to subtract 15.5 squared to move it over. Let's make that 0.5. And that gives me a number. Negative 65.25. And that's going to equal negative 2, I'm just going to keep it black, 15 times 15.5 times the cosine of c. Okay. Now, again, I just have one term, but now I can divide both sides by this in order to get c by itself. And that's the tricky part, so you have to be very careful. So if I want to take this and divide it by all of this, the thing you have to be careful is I don't actually want to type it in this way. I want to do one big parentheses and just use my times symbol. So I'm going to divide by, since there's more than one thing at the bottom, I have to use parentheses. If you don't use parentheses, you will get it wrong every time. So I'm going to type in negative 2 times 15 times 15.5. It's important that you write it in this way if you're going to type it in all at once. Or, if you want to be careful, type this in your calculator and get a number and then divide by it. So I'm going to show you both ways. So if I hit enter, I get cosine of c is approximately 0.140322, blah, 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 blah. So let me show you the other way you could have done this. I could have typed in negative 2 times 15 times 15.5. Okay. And got negative 465. So I could have wrote my equation as negative 65.25 equals negative 465 cosine of c. Then I could have done negative 65.25 divided by my answer, or retype it in, and you get the same thing. Whichever way is going to keep you from making mistakes is what I suggest you do. But now I need to get c by itself. So remember, you have to take the inverse of this answer, okay, of this previous answer. So that's what I'm going to do. I'm going to hit second cosine, second answer, hit enter, and now I get cosine, or the angle c, is approximately 81.9 degrees. So now that I know that, 81.9 degrees, it's really easy for me to now find angle A. Angle A, again, remember, is just one of three angles of a triangle. So I'm going to do 180 minus 50 minus my 81.9. So I'm going to take my 180 degrees minus my 50 degrees minus my 81.9. And now I'm going to get that it's A is approximately 48.1 degrees. And now I have solved for my triangle because now I have found the three missing pieces. So I'm going to talk to you about why would you not want to switch to law of cosines, or from law of cosines to law of sines. Now, angle C ended up being an acute angle. That is okay. So if you would have been a person who switched from law of sines to law of sines from law of cosines, you actually would have got the right answer. However, if angle C would have been obtuse, you would have gotten a wrong answer and you wouldn't have understood why. So, why don't you get the correct answer every time if you switch? Well, if you remember how inverse sine and inverse cosine are defined, inverse sine only gives you solutions from negative 90 to positive 90. So if you remember that, these are the only answers that your calculator will give you when you type in inverse sine into your calculator. So the only answers that make sense for a triangle are 0 to 90, which is an acute angle. And we know these probably aren't right triangles, so it would give you an acute answer. But inverse cosine will give you any answer from 0 to 180. So if there's an obtuse triangle, using inverse cosine will actually give you the correct answer. So if we had an obtuse triangle, we switched, it's not going to give me the right answer. It's actually going to give me a false answer because it's going to try to squish the answer into 0 and 90, which doesn't make sense. So again, if you start with law of cosines, I would always stay with law of cosines unless you know the largest angle already. And if you start with law of sines, stick with law of sines. I hope you feel a little bit better about the law of sines and law of cosines, and that you're able to find angle measures and sine lengths using each one.